Okay, so we're going to take the ideas that we talked about yesterday, and we're going to change one small thing, and changing that one small thing has a profound impact on everything that we do from this point on. So, what are we going to do? We're going to do that. You've seen that picture before. We used a picture like it yesterday. What's the difference between what we did yesterday and what we're doing now? Ethan?
Where it says 65 degrees, it's like the measure of the angle instead of the number.
Okay, anything else you notice? Andy?
2 lines are parallel.
Beautiful. We're going to start with the parallel lines here. And I'm going to take a different approach here. I'm going to see what you can tell me, because I think this is pretty intuitive, and if you can figure it out, it'll make the lesson a lot easier instead of me just talking to you. Okay, so let's start simple. How big is angle 6? Why? Okay, easy. All right, how big is angle 5? How much? Thank you. Why? Give me, let's just go one reason for now. Why is it 115? Camille? Yeah, one of the 65-degree angles. Okay, and then lastly, how big is angle 7? 2 reasons why this is 115, please. Andy? That's 1. Outstanding. Okay, that has nothing to do with what we did yesterday. What does have to do with what we did yesterday is the question of, do you have any idea how big angles 1, 2, 3, or 4 are? Tommy, what do you think?
Yes, because like 5 and 1 and 7 and 4 are the same because they're corresponding, and then that's the same with 2 and then the 65 degree, and then 3 and 6.
Okay, hold on, so let's back up. Do we all agree that if Tommy can get us the measure of one of those angles, 1, 2, 3, or 4, that we can get the other 3?
Yeah.
Okay, good. So let's do angle 1.
Well, it'll be 115 degrees.
So you're suggesting this is 115 degrees because why?
It's corresponding to angle 5.
Good. Now, that's true based on one simple fact. Do you know that those corresponding angles are congruent? Tommy?
Yes.
Because?
The lines are parallel. No.
But you can't prove that.
So no,
No.
do not.
Do you all agree with what he's saying, though?
Yeah.
Okay, so this is where we enter into a weird discussion, and you'll see when we start talking about the theorems, we have to start somewhere. So Tommy's decided I'm going to start with that angle 1 up there and say, okay, those corresponding angles are congruent. And we all agree with them, so we're going to go with it. All right, Tommy, finish this up. If angle 1 is 15, how big are the other 3?
2 and 3 are 65, and then 4 is 115.
All right, now that we're done and we have all the angle measures up there, what do you notice? My TV.
Wait, there.
No?
No.
Anybody else? How many different angle measures do we have? 2. That's it. Okay. What else do you notice? Well, you didn't. I told you that. Do you notice anything else? Look at acute and obtuse. How many acute angles are in that picture? 4. How many obtuse angles? 4. Okay. And these are the things you want to keep in mind when we're working through this problem. All right, so let's talk about alternate interior angles in this picture. Which ones are the alternate interior angles? Okay. 4 and 5 and 3 and the 65 degrees. What do you notice about the alternate interior angles? Patrick?
They like both equal the same amount.
Okay. So let's go through our list from yesterday. We had corresponding angles, we had alternate interior angles, whoops, alternate exterior angles, consecutive interior angles, and consecutive exterior angles. All right, so Tommy, we got this from you already, that the corresponding angles are congruent just because you said so. I like it. And Patrick, you just said that the alternate interior angles are what?
Oh, the equals and wrong.
Okay, they're also congruent. What about the alternate exterior angles? Let me change colors here. Which ones are the alternate exterior angles? Keep going.
Oh, 1 and 7 and 2 and 6.
1 and 7 and 2 and 6. What's true about those angles?
They're congruent.
Those are also congruent. All right, moving right along here. How about the consecutive interior angles? Which ones are they? Sean? I know things are getting a little muddled up there, but bear with me.
5 and 4 and 65.
Say again, I'm sorry.
3 and 5 and 4 and 65.
3 and 5 and 4 and 65. Okay, so 3 and 5 and 4 and 65. What's the relationship between those two angles, Sean?
Out of the two possible angle measures, each one is either one. And, oh, the supplementary to each other.
And last but not least, I think I'm running out of colors here. Nope, still have purple. What about the consecutive exterior angles? Where are they? Andy?
1 and 6 and 2 and 7.
1 and 6. Let's do big circle. 1 and 6 and 2 and 7. And what's the relationship between those angles? Supplementary. All right, before I move on, is everybody good with this? Now, there's one small problem here. It's kind of a big problem. This entire discussion is based on one simple premise. And if it's wrong, we're going to have to beat up Tommy. So I hope it's right, or it could get ugly in here. If he's right, do you all see why that information would work? If he's wrong, do you see why we have to beat him up? We wasted a ton of time on something that doesn't work. Okay, so all right, let's move on. Okay, so now we've pretty much done the lesson. You guys did all the work. Now I'm just going to give you all the fancy schmancy geometry stuff. Okay? There's the first one. Now, strangely enough, you think I would have worked this out with Tommy ahead of time. He did exactly what I wanted him to do, and he started with corresponding angles. And as this slide says, you have to start somewhere. Okay, now, before you start writing stuff down, just wait a second. Let me talk about some words here. There's a word up there called a postulate. Do you have any idea what a postulate is? Okay. There are certain, in fact, most of the stuff we do in here, we're going to end up proving is true. Using a proof, using a discussion, however, there are some things that you'll just have to trust me on. Those things that you trust me on are called postulates. Okay. We're just trusting Tommy that he knows what he's talking about. Okay? The Tommy postulate. We're assuming he knows what he's doing and that that statement is true. We're not going to prove it, you're just going to have to believe him. And that's what the word postulate means. It's an assumption. So what he said is, if those lines are parallel, then the corresponding angles are congruent. Which is what started the whole ball rolling for us. Now, what are you writing down on this slide? That wasn't a rhetorical question. What are you writing down? Are you writing down the whole thing? Are you writing down the stuff in red? Are you including the picture? Okay.
I'm writing down the definition of corresponding angles postulate and then the lines equals corresponding.
Okay. So again, remember what I said from day one. Don't write down stuff that A, doesn't make any sense to you, or B, you're not going to use in the future. If this stuff in red is enough for you to understand the theorem, then just write down the red. If you want to write down every word on that slide, go right ahead. Might take a while, but knock yourself out. So far, it looks like we're not going to have to beat them, huh? But we'll see. We have a couple more slides to go. Everything we do from this point on can be proven using the Tommy postulate. Are we good? We need another minute on this slide.
Yeah.
Yeah, another minute? Okay. While you're finishing up, one other thing I want to mention. What's very important in this postulate is that the lines are parallel. If you don't know the lines are parallel, this isn't true. It doesn't work. So the stuff we did yesterday, those corresponding angles weren't congruent. They were just corresponding angles. Now that the lines are parallel, all of a sudden we've got them being congruent. All right. Now the next 4 slides are pretty much just the theorems that we've already discussed. So I'm going to go through them quickly. What I would suggest is that you just write down the red stuff, because number 1, it'll speed up the process, and number 2, that's really all you need to know. So for instance, we know now that if the lines are parallel, the alternate interior angles have to be congruent. We did that. Okay. Notice it says prove it. Now, how would you go about proving that these 2 things are true? Well, I'll show you one proof, and then we'll skip the rest of them, because we don't need to bother with everyone. Let's suppose I label this angle angle 2. Using the Tommy postulate, how big is angle 2? That's, hold on. 2 and 3 are congruent. Why? Okay, but that's not the Tommy postulate, right? Okay, so why would 2, what is 2 congruent to using the Tommy postulate? 4, right, because they're corresponding angles. So now what happens is, we have angle 2 equal to angle 3, we have angle 2 equal to angle 4. If 2 things are equal to the same thing, then they have to be equal. Does that make sense? And that's what's called a proof. Done. Whoops. Okay. Consecutive interior angles are supplementary. We knew that already. But again, if the lines are parallel, then the consecutive interior angles are supplementary. How are you going to prove that one? Well, introduce another angle above angle 5, call it angle 4. It's corresponding to angle 6. Because of the Tommy postulate, angle 4 and angle 5 are supplementary. Angle 4 and angle 6 are congruent. Do a little bit of substitution. You're done. Consecutive exterior are supplementary. And last but not least, alternate exterior angles. So you might be thinking to yourself, I gotta go home, I gotta memorize this. I gotta memorize that the alternate interior angles are congruent and that the alternate exterior angles are congruent. And it's simpler than that. If we go back to the first problem we did, we talked about only 2 types of angles in that picture. You've got acute angles, you've got obtuse angles. Can an acute angle ever be congruent to an obtuse angle? No. So forget about the theorems for a second and just look at that picture. And if I say to you, what's the relationship between angle 1 and angle 6? What would you tell me? The answer to that question is only one of 2 answers. They're congruent or they're supplementary. Are 1 and 6 congruent or supplementary? Supplementary. Why? Well, 2 reasons for why. Number 1 is that angle 1 is obtuse and angle 6 is acute. They can't be congruent, so they must be supplementary. Answer number 2, which is the more geometric way to do it, what kind of angles are 1 and 6? No. 1 and 6 are not corresponding angles. John?
Consecutive exterior.
Consecutive exterior. Okay? So don't make this more complicated than it has to be. Again, going back to the KISS method. Keep it simple, stupid. Do some thought process, do some analysis. Don't memorize stuff. Approach it from an analytical standpoint. And now since we're talking about angles, I know you love this, but we can start doing some algebra. Let's skip that one for a second and do this first. We can start setting up some algebra equations just like we did with segments and just like we did with the other angles. So here are some hints to help you. Which pair of angles are you talking about? We've got 10 different pairs of angles now. Vertical, adjacent, linear pair, supplementary, complementary, alternate interior, corresponding, alternate exterior, consecutive interior, consecutive exterior. Step 2. You're only going to do one of two things. You're going to set those measures equal to each other because they're congruent, or you're going to add them up and set them equal to 180. That's it. No other possibilities, so don't overcomplicate it. Step 3, solve for the variable. Step 4, answer the question. Is the problem asking you to just find the variable? Is the problem asking you to find a particular angle measure? Anybody know if the Cubs won last night?
Yeah, they did.
They did. Good. 2-0?
3-0.
3-0. They scored again. Okay, good. All right, got all 4 steps? All right, no problem. How are we doing for time? Oh, okay. Pregunta. El baño? Sí. Adios. Did you just give me a peace out? Nice. Don't forget to pass.
This?
That would be the pass, yeah. If you pull it out and look at it, you'll know the answer to your own question. What does it say on it?
Oh.
So you think that's probably the hall pass?
Yes.
Good. Don't drop it, it makes a lot of noise. And leave the door open so you don't get locked out. And have a nice trip.
Why do you guys lock the doors?
What's that?
Why do you lock the doors?
We don't have a choice. They lock on we don't have the capability to unlock them just for a safety issue.
You just carry around that huge wall pass?
Yeah, that's not my problem.
That's dirty, that's...
Well, I clean the hall pass on a regular basis.
It could be worse.
Okay, let's go back one slide to this. I don't want to make a big deal out of this because I think it's fairly obvious, but if that transversal happens to be perpendicular, pretty much everything we've talked about still applies, but it's made a lot simpler because everything's a right angle. Right angle, 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 right angle. The alternate interior angles are still congruent. They're both 90. The consecutive exterior angles are still supplementary. 90 plus 90, 180. Okay, so again, I didn't want to make a big deal out of that, but I included it just so I can say I covered it. Okay, let's look at some problems here. We'll start with that. All right, so the two angles, let's forget about angle 4 for a second. The two angles we're going to focus on are the two marked angles. This angle and this angle. So following our 4 steps, which pair of angles are those two purple angles? They are supplementary, but
Consecutive exterior.
yeah, they're consecutive exterior, which means they're supplementary. Okay, good. So what should I do with the measures? Set them equal, or add them up and set them equal to 180?
Add them up, 7 equals.
Add them up, set them equal to 180. I can do that. 2x plus 15 plus $1.25 is equal to 180. That's 140, so 2x is equal to 40, so x is a pretty answer of 20. Okay, halfway done. How do I find angle 4? And by the way, there is at least 2 ways to find angle 4.
Well, it's equal to 125 because they're corresponding.
Answer number 1, it's equal to 125 because it's corresponding with the 125-degree angle. Good. Jack?
It's supplementary to 2x plus 15.
Keep-
And you add them equal to 180.
Good. How big is this angle? How could I find the measure of that angle?
55. Oh, 2 times 20.
There you go.
16.
Put 20 in there. Okay. Put 20 in there, find that angle, and angle 4 are supplementary. So there's 2. Any other ideas?
We should just do 125 minus 180 and just get the answer by doing algebra.
To get to 55?
Yeah.
Yeah.
So let's not give you the algebra.
Because we need to find angle, we need to find the measure of x. So you're taking a different approach here. You're saying, if I'm hearing you correctly, that's 125, so that has to be 55. So then 2x plus 15 has to equal 55. What happens when I solve that? Yeah, same, we're good. Yeah, there's another method to approach. Okay. Make sense? All right, let's try another one. Oh, yeah, which theorem did we use? What kind of angles did we say those are? Consecutive exterior, good. Okay, so now I introduced another variable. This one's a little sneakier because one of the things I've said is keep the same variables together. So I'd like to work with just the x's. The problem is, if I look at that and that, what pair of angles are those? Understand the problem? That's not a pair of angles we've talked about. Those are alternate, but one's on the outside and one's on the inside. So it's not a pair that we talked about. What do I do with those then? Do I set them equal or do I add them up and set them equal to 180? Ken?
Add them up and set them equal to 180, because 3x is the same as up 1 over.
Say that again.
So,
3x is the same as which angle?
1 next to 9x plus 12, to the right of that.
That?
Yeah,
What kind of angles are those two? Corresponding. Okay, so this would be 3x. And therefore, add them up and set them equal to 180. Good. Another way. Oh, well, I could say this is 3x. What kind of angles are these? Consecutive exterior. What do you know about consecutive exterior? No.
They're supplementary.
Supplementary. But again, let's back up a little bit. Using the KISS method, acute or obtuse? Acute or obtuse? Can an acute angle and an obtuse angle be congruent? Nope, so that gives us the other alternative, 3x plus 9x plus 12 is equal to $1.80. 12x equals 168. Little help here, please.
14.
Thank you. All right, so that takes care of x. Now I got to find there is no angle 3. Well, that's kind of a problem. Let's change this to find y. How do I find the value of y? KK.
You plug in 14 for 3x,
Okay, so 14 times 3 is 30 plus 12 is 42. Got it?
And then you would add them together and equal them to 180.
Beautiful. 4y minus 10 plus 42 is equal to 180. 4y, that's 32, bringing that over there is 148. So y is equal to 74, 37?
Yeah.
Yes? Hot diggity. Good. Any problems so far? Does this make logical sense? And that's what I'm trying to emphasize, is that if you memorize less and bring logic into it more, I think your life will be a lot easier. And the problems will be a lot easier. Okay. New type of problem. This is what's called the Crook problem. They pop up frequently. To solve this problem, we're going to introduce something called an auxiliary line. And what the auxiliary line does, 03, right? September here?
Yes.
Okay, good. The auxiliary line is a line that we draw in that allows us to solve the problem. And it looks something like this. I have no idea how big a lot of these angles are, so this is what's called a crook. A crook is like a bend. A crook is never mind. It's just the bend. So you're going to draw a line through that vertex, through the crook, so that all three of these lines are parallel. Okay? If there's more than one crook, you draw in more than one line. And then the process is pretty simple. You work from the bottom up, you work from the top down. Okay. I need to find angle 1. Notice my auxiliary line has split angle 1 into two angles. Let's call this angle alpha and this angle beta. You guys okay with the Greek letters? Alpha looks like a fishy, beta looks like a bee with a tail. Yeah? It's time to run with the big dogs, so we're going to use some Greek letters. If I can find alpha and I can find beta, then I can find angle 1. Are we all in agreement? Because alpha plus beta equals angle 1. All right, we'll start with beta. How big is beta? Go.
118?
Nope.
No.
And?
62.
Nope.
128?
Nope. 36. Bye, Stephen.
62, 180, 174.
What kind of angles are beta and the 144? Good. They are consecutive interior angles. All right, good. Forget about the bottom now. Forget about all this stuff. How big is alpha? No? 62. Why? Who said 62? Why, Lily?
Because the alternate interior angle.
There you go. So therefore, angle 1 is equal to 62 plus 36, which is 98 degrees. So it starts with the auxiliary line, breaking the angle that we're looking for into two parts. Those parts will seldomly be equal. Common mistake with Crook problems is people think that that's split in half. That's not the case. Split into two separate parts. Top down, bottom up, good to go. We're all done. Okay. Lot of information today. I bombarded you with a ton of stuff. Again, the KISS method works great with this. Go back to the original picture, remember some of the basic rules. They're only acute or obtuse. There's only two angle measures in that picture. They're either congruent or they're supplementary. No other possibility. All right? Day 2 tonight, quiz on Friday. More fun stuff tomorrow. What's dress up day tomorrow, do we know?
Jackson.
Decades. What decades is the span?
You get to choose.
I can do whatever, so I could choose the 2018 decade? Okay, awesome. That's what I like. Just wear my teaching clothes tomorrow?
I'm not wearing it. Don't be my age. 60s.
You're just gonna be a rebel?
Not necessarily.
I don't think I'm.